This is some data I prepared earlier. So let's go 3D, plot, and so this is basically just 9 clusters of data, one of which has a larger spread than the other 8. Let's probably enable the nodes. So let's reduce that a little bit, size a bit. Okay, so I'm going to manually tell them where the nodes start. So 1, 2, 3, 4. It's always a bit hit and miss getting this right. And nine, 1, 2, 3. Yep, so we've got 9 nodes there. So it's giving the standard. In fact, I need to change it to the square root of, but at the minute that's actually variance. But this will be the standard deviation of all the data points for the data in each of the nodes. So I can turn on an exclusion sphere, which we can put anywhere. Can resize it. So at the minute it's not doing any loops, but the exclusion sphere does remove data points. You can see the standard deviation or variance will vary depending on how data points are removed from the system. I can turn off. I can turn on the include spheres, which have a size. Again, you can right click on the sphere controls and you can change the density. So it will be different on a full HD screen. But as you reduce the size, you actually remove points. So you'll see that these values will vary, depend on the radius of the include spheres. So data points are a function of being outside the exclude sphere and inside the include sphere. So go back to here. So that's not the that's just the normal sphere. This is the exclude sphere. So we can reposition that. So if the exclude sphere is present, then it's a function of that being outside that. If the include spheres are present, it's also a function of the or it being the stats here. Outside the exclude sphere, inside the include sphere, if either or neither or both are present. Okay, so we can I can't really do the loops with this data set, but if the distant loops thing is present, then the most distant point for each loop would then produce one or more loop counts. And obviously, because we've got the distant point things enabled, then the stats are now based on the most distant point of each loop exiting the exclude sphere, and because the include spheres are present, that most distant point must therefore be within the include sphere. If the include spheres are not present, then it's just the most distant point within the loop that exits and re-enters the exclude sphere. So the distant points are calculated first, and then they must be present within the include sphere, which is centered on the kmeans node. It doesn't reposition itself. It stays where it's put. And you can store the reference spheres. So you can see them. They are there. Turn off. So include, exclude. You just can't actually see them because I've turned this thing down. So you're only going to get, hang on, you're only going to get, what can I put? So you've got red spheres appearing there. You can see one there. So you've got red sphere there. That's the reference one. So I can make this red one a reference sphere. So if I say remove and then store, that becomes reference one. If I move around, then you see the red one in the center here is the new. So it's all working really nicely. This is all your red spheres. These are your reference yellow spheres. I need to work on the export side so that when you're not using the loops, you've just got the clusters. So if we go back a step and turn off distant loops, remove the references, then, like I said earlier, these stats are now based on it'll be the standard deviation of the data points within that cluster. And I said earlier, one of these clusters has a larger spread than the others. It's this purple one here. So to identify which one that is, what we can do is we can say, go through the list, highlight, you can't really see that clearly. Second button down there, highlight cluster node 1. So if we turn that on, what we've got to turn off first, we turn off the exclude. Okay, so now if we go back to 1, we go 1, 2, 3, 4, 5. So cluster 5, which is 0.04. So all the others are around 0.24, or 0.22 to 0.24, whereas the fifth one is 0.05 because it does have a larger spread, so it all fits. Okay, job done.